I welcome you all in this video session. Today we are going to discuss about interrupts of 8085. What are interrupts? Interrupts are nothing but it is a disturbance or immediate call from the input-output device or from the another master, which the microprocessor stops its main function and gets ready to clear the interrupts from outside world or from input-output device. Introduction. Interrupt is a process where an external device can get the attention of the microprocessor. The process starts from the input-output device. The process is asynchronous. An interrupt is considered to be an emergency signal that may be serviced. The microprocessor may respond to it as soon as possible. What happens when microprocessor is interrupted? When a microprocessor receives an interrupt signal, it suspends the current execution program and jumps to an interrupt service routine to respond the incoming interrupt. That means when a microprocessor gets any interrupt from outside master or input-output device, microprocessor stops its current operation and it jumps to interrupt service routine to respond to the incoming interrupt. Each interrupt will probably have its own ISR. When the interrupt signal arrives, the processor will break its routine, go to a different routine, that is interrupt service routine, complete the interrupt service routine, ISR, go back to the regular routine. In order to execute an interrupt routine, the processor should be able to accept interrupts. Interrupt enable. Save the last content of the program counter. Know where to go in the program memory to execute the ISR. Tell the outside world that it is executing an interrupt. Go back to the saved program counter location when finished. Interrupts increase processor system efficiency by letting input-output device request CPU time only when that device needs immediate attention. An interrupt is a subroutine call initialized by external hardware. The request is asynchronous. It may occur at any point in a program's execution. That means if any point it occurs, the microprocessor has to leave its original operation for that interrupt and go to clear that interrupt. Now the classification of interrupts. Interrupts can be classified into two types. Maskable interrupts, that means can be delayed or rejected. Non-maskable interrupts cannot be delayed or rejected. Here we can see now by name it can, maskable. If there is some mask in interrupt, that means while coming, when an interrupt comes, we can stop it, we can reject it. But non-maskable, there is no mode of stopping, no mask is there, no mode of stopping, so we cannot stop it. It cannot be delayed or rejected. Interrupts can also be classified into vectored. The address of the service routine is hardwired. Non-vectored, the address of the service routine needs to be supplied externally by the device. That means the address of the service routine is known. Here the address of the service routine has to be supplied. Non-maskable interrupt input. The microprocessor is interrupted when a logic signal is supplied to this type of input. Maskable interrupt input, the microprocessor unit is interrupted only if that particular input is enabled. It is enabled or disabled under program control. If disabled, an interrupt signal is ignored by microprocessor unit. See, if interrupt is enabled, then only a microprocessor will be clearing the interrupt. But it is disabled, then the microprocessor will reject it or delay it. Respond to interrupt. Responding to an interrupt may be immediate or delayed, depending on whether the interrupt is maskable or non-maskable, or whether interrupts are being masked or not. Microprocessor completes its current machine cycle. There are two ways of redirecting the execution to the ISR depending on whether the interrupt is vectored or non-vectored. Vectored, the address of the subroutine is already known to the microprocessor. That means the data the data's address is already known from where the data has to be, which address location the data has to be cleared. But in non-vectored, the device will have to supply the address of the subroutine to the microprocessor. That means the data's address has to be supplied by the device from where the interrupt has been occurred. The processing of the current instruction is completed. An interrupt machine cycle is executed during which the PC, that means program counter, is saved and control is transferred to an appropriate memory location. The state of the microprocessor unit is saved. If more than one input device is associated with the location transferred to, the highest priority device requesting an interrupt is identified. A subroutine is executed which services the interrupt input-output device. The saved state of the microprocessor is restored. Control is returned to the instruction that follows the interrupted instruction. Now the 8085 interrupt structure. In the last session we saw the 5 interrupt inputs, that is trap, non-maskable. See, trap is non-maskable with highest priority among all the pins. So if any interrupts come from trap, we cannot stop that because it's non-maskable. RST 7.5, RST 6.5, RST 5.5, INTR. These are other interrupts of 8085. The EI, that is enabled interrupt instruction, is a 1 byte instruction and is used to enable the maskable interrupts. The DI instruction is, that is disabled instruction, is a 1 byte instruction and is used to disable the maskable interrupts. The 8085 has a single non-maskable interrupt. The 8085 has 5 interrupt inputs. The INTR input. The INTR input is the only non-vectored interrupt. INTR is maskable using the enable interrupt, disable interrupt instruction pairs. RST 5.5, RST 6.5, RST 7.5 are all automatically vectored. RST 5.5, RST 6.5 and RST 7.5 are all maskable. Thank you. I hope you liked this session. Thank you.